I'm Kyungyun Lee, and today I'm going to talk about, so tell me, what is your music taste? So before I get into talk, I'll introduce myself. I'm a master's student at Music and Audio Computing Lab in KAIST, South Korea. And my research area is called music information retrieval. So it's like extracting some information from music and apply it to like real world applications, like for example, recommendation. And for me, like I use combination of music or audio, signal processing, and machine learning to achieve that. And many people might be wondering why I'm here all the way from Korea. I grew up in both Korea and Canada, so I lived in Victoria for a really long time. So that's why I'm here. So today, the main topic is music taste and recommendation. So first, we'll talk about why we should care about such thing. And then second, we'll learn about how to model music taste. And I'll introduce Statify, which is a website that I built. And then lastly, we'll briefly touch on the concept of music recommendation. So first, why should we really care about music taste and recommendation? Because, we all love music. I don't know why, but the sound is not coming on. Well, we love different music. Oh, it's fine, yeah. We love different music. For example, some people might like really heavy metal. Some people like acoustic pop. Like some people like BTS. We like combination of different music. And most importantly, we love different music with different reason. What I mean by this is that two people might like the same music for a different reason. You might like it because the lyric is really good. You might like it because the bass line is really good. You might like the singer. Or you might just be a fan of the artist. So we got this. We know that music taste is diverse. Every single person is different in the world. And we also have another problem. There are way too many songs in the world for us to listen. So let's say one song is around like 4 minutes on average. And I'm going to say, very roughly, there's like 50 million songs in the world or in Spotify's database, for example. In order to listen to all of them, it will take 380 years, 6 months, 6 days, 9 hours, 20 minutes, so on. And that's impossible for humans, right? And there's also a website called quantify, where it will give you songs that have never been heard or have been only heard very few times on Spotify. So you can go to Spotify and find out what the song is. So the job of the recommender system is like going through the stars, and it will find songs that you will like out of those. It will find songs that you will not like, not your friends. And the importance of recommender system is that we live in a world that is full of data, and we need to continue to filter out what we like and what we don't like. So having a recommender system is quite useful, especially in today's world. So then, how do recommender systems really, know my music taste and differentiate my music taste from my friend's music taste? And we'll go through 2 parts. The first part is to model music taste, like individual person's music taste. And we'll learn about how to do this. What I mean by music taste modeling is I'm going to quantitatively represent a very descriptive and subjective music taste into numbers, because we all know the computers only understand numbers. It's not going to understand something like, oh, I love to listen to heavy metal with screaming vocal, dark and chaotic sounds and blah, blah, blah. It will not understand that. We want to process that into numbers so the computer can do something about it. But music taste is very difficult to describe even to your friends. For example, I looked at Reddit. I Googled how do you describe your music taste? And there's some strange things like musical ADHD, which totally kind of makes sense. I agree with that. So how should we really model or represent this music taste into numbers? I'm going to introduce Statify, which is a website that I built just for fun, relating to my research and stuff like that. So I have the link at the end of the slide so you can check it out. Now it uses, I built this with Django, Spotify Web API, and Spotify, which is the Python wrapper for this API. And I use various visualization libraries like PyCascades. Also, for computing and machine learning, I used NumPy and scikit-learn. So Spotify Web API, it offers lots of different functions like searching for a track or album or artist, creating a playlist, showing the current user's top tracks or albums, and etc. But my favorite part of the web API is they provide audio features for each track in the database. So for example, the example audio of the audio feature is danceability, like how danceable is the music. 0 is like not danceable at all, and 1 is very, very danceable. And acousticness, is the track an acoustic track or is it not? And also, for example, like valence, how positive or how negative, like how sad or how happy is the track. So these are some of the features that are provided by the API. And it's very easy to get that feature if you use Spotted Py, the Python wrapper. So you just do the normal thing, like you go to the web API website, you get your client ID and all those things, and you do the authorization. And you need to initialize the Spotify web API object by calling the SpotedPy.Spotify. And each track in Spotify, they have a unique ID. You can get that from the web app of Spotify. And you just call sp, the object, dot audio features with the track ID, and then you get something like this. It's like a JSON or a dictionary of all the audio features plus other metadata. And I got an example for Island in the Sun by Weezer, if anyone knows. So how are these audio features computed? You know, like how does Spotify get these audio features? For example, for the Island in the Sun, if you see acousticness is like 0.00719, danceability is 0.654, and etc. So how are these computed? So EchoNest is a company that was founded from MIT Media Lab in 2005, and they're very famous for creating a really large music database, and they use a lot of techniques like signal processing, machine learning, and web crawling to collect a lot of data for each of the tracks. And in 2014, Spotify acquired EchoNest. So since then, Spotify has been using the database that EchoNest has created. So this is how all those features are there on the web API. And I'm going to use 8 of those audio features to model tracks for Spotify's tracks, for example. So I'm going to use 8 of 8 as such: danceability, energy, loudness, acoustics, blah, 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 until tempo. So for the Island in the Sun, this is how I'm going to model it. Island in the Sun will be represented by just 8 of these numbers. And the most important thing is the order of these features must be consistent when you're modeling all the other tracks. So you don't need to follow my order. You can order these in any order you want, but you need to be consistent throughout your application. So we just modeled a track with 8 numbers. Then how can I model my music taste with 8 numbers? I'm going to use myself as an example. I got my top 50 tracks that I've listened to the most in the last past month or two. And these are the artists. I have quite a lot of like rock and a little bit of like jazz. So what I'm going to do is I computed the audio features, the 8-dimensional vectors. I modeled each track in the my top 50 tracks into 8 numbers. And I'm just simply going to average all the features so that it can represent my music taste. So that's me there. So my music taste is now represented with just 8 numbers. And this is simply the average of all the features from my top 50 playlist. And I'm just going to show you like what Statify, the website that I built, it shows top 10 genres I've listened to the most. And as you can see, I listen to mostly rock, like various kinds of rock, and a little bit of pop. And also, I plotted the box plot of all the audio features. So how you read this is the bold line through the middle is the mean of the audio feature, and the height of the box is the variance. So what I think is that small variance might mean that you really care about the feature. So for example, the green one at the top, the small box, is the loudness. So I seem to really like loud songs. And if you see the box in the bottom, the orange box, or red, I seem to really not listen to live recordings of the songs. I tend to listen to the actual original track, recording track. So you can interpret all sorts of things from this box plot as well. And I also offer another feature where you can compare your top 50 playlist with the popular playlist that is provided by Spotify. So these three are playlists that are provided by Spotify, and it features really popular tracks from around the world. So I'm going to choose the global top 50, and this is from, I think, 2 weeks ago. So as you can see, Ariana Grande is at the top, and we have other artists. So in the app, in the website, I'm going to click Global Top 50 and My Top 50 and do analysis. And this is the histogram of this two playlists. And what I can see, my top track is orange. So I can see that my tracks are less danceable than the global top 50 tracks. And in general, mine has a bit more energy, and so on. And you can see that the popularity at the bottom, the middle bottom, I listen to songs with less popularity and also a lot of popularity. And obviously, the global top 50 has it's all popular. So you can check that out on the website. So we have represented music at a track and your user taste with 8 numbers. But I chose 8 numbers, eight of the audio features. But are these really sufficient to really represent music and user taste? And I'm going to do a 3-way comparison. I'm going to compare Discover Weekly, which is a playlist that is recommended to you every week. So it knows your music taste. Spotify knows your music taste and will recommend some songs to you. So it has, I think 20 songs. I'm not sure. And I'm going to compare that with the global top 50 and my top 50 and see how the tracks look like. But the problem is, I have 8-dimensional feature vector, and I can't plot that into 2 dimensions, which is the space that we have on the screen. So I'm going to reduce the dimension to 2 using one of the technique, principal component analysis. So it just finds 2 most meaningful feature from 8, and then it will reduce down to that. And this is the result. So as you can see, each dot represents a track. And for example, that red dot is Bohemian Rhapsody by Queen, and the blue dot is Psycho by Muse. And as you can see, the big red dots are the global top 50 tracks. They're clustered in the bottom left corner. And Statify, which is my track, it's really spread out. And surprisingly, Discover Weekly is also, it kind of looks like my taste. So from here we can see that just using 8 of those audio features, it is sufficient to really describe a track and describe user taste, because we can see that it represents my music taste instead of the global top 50. And Discover Weekly does a really good job. So we have just finished modeling user taste. So the next thing is we just need to do recommendation. And recommendation is very simple. It's just like ranking. So it's going to rank the songs that you like the most to the songs that you like the least. But in order to rank, you need some kind of a metric. And I'm going to measure similarity from my user taste to all the other tracks in the database, and then find the songs that is closest to my music taste, because all the user music taste and the tracks are represented with just 8 numbers. And out of many similarity metrics, I'm going to use cosine similarity, which is measuring the angle between 2 vectors. And you can write your own function with Python very easily, but I used scikit-learn's function that's provided, which makes it very simple. And recall that my music taste looks like this with 8 numbers. And I took 4 tracks as an example, some rock, folk, pop, and I represented them with 8 numbers as well. And then I'm just simply going to compute cosine similarity between my music taste and the 4 tracks. And here I have Basket Case by Green Day, and I compute it like that. It's very simple. And then I ranked. And it does really good, because if you can recall, I listen to mostly rock and a little bit of pop, and it does rank in the correct order. so we can see like how the recommendation actually works. And this is how the content-based recommendation works, and even for Spotify, they use content-based recommendation as well as other types of recommendation, but this is how it works in essence. So we have commonly have two types of very popular recommendation methods that's currently used in many of the services. And the first one is just what we talked about, content-based. And content-based means using the content of, for example, music. So we use audio features which really describe how the music sounds like. And we recommend similar content to the user. And then the second one is collaborative, which doesn't use any of the content information. It only uses other people's user data and my user data. And user data includes like listening history of the song, likes, artist follows, and etc. Now I'll explain a little bit more about what this collaborative method is. I brought these, and I'm going to explain what collaborative filtering is. And collaborative filtering is a very popular recommendation algorithm. It was popularized by Netflix. And how it works is we have Hiccup and Toothless. And Hiccup, the boy, is like, I like H for Hiccup, and X and Y and Z. And then Toothless says, I like T for Toothless, and X and Y and Z. And you have to note that here they have X and Y and Z in common that they like. And then the CF algorithm genie comes and thinks and says, Hiccup, I think you will like T. And then this genie tells Toothless, Toothless, I think you will like H. And guess what? Will they be happy or not? They'll be very happy. You know, they'll be very happy. Because the CF algorithm, it assumes that people who have liked similar things, they'll have similar taste. So they liked X and Y and Z in common, so the algorithm recommended the ones that each of them didn't listen to. And it works really well. And as you can see, like Netflix works really well. Netflix is very well known to use this algorithm. So recommending without user data, it works. Only if you have like a lot of data though. Okay, then we talked about like, modeling with 8 audio features and all these things. So why did we talk about all of that if CF algorithm that doesn't use any of those content information works well? Because CF algorithm has a really big downside, and it's very well known for cold start and long tail problem. And cold start problem, you'll understand why it's named cold start. For example, a new user registers to Spotify. That user have never listened to any of the songs because he or she just registered. So in that case, the algorithm cannot recommend any songs to that user because he or she didn't listen to any of them. And also, if an artist released a new song, no one listened to that song yet. If no one listened to it, we can't recommend that to another user. So this is a really big problem. And secondly, we have a long tail problem where songs on the tail end is less popular, so CF algorithm is unable to recommend the songs that are less popular and people didn't really listen to. It will only recommend the songs in the popular side. So if you use CF algorithm only, you'll see that your algorithm continues to recommend popular songs, not the songs on the tail end. So it's very hard to do discovery of new songs, for example. So the next step, as you can see, is, okay, let's combine the content-based and collaborative filtering, and obviously you'll think that will get better. And it really does get better. And a lot of services, for example, like Spotify, they do both content-based and collaborative filtering method. And I'm not going to go on to explain how they do that and everything, but I included some references at the end so you can read a little bit more. There's a really great blog post and some research papers on this. And you can ask me any questions if you have. And yeah, now you know how your music is recommended to you every day, because I'm sure a lot of people use Spotify. And I also wonder how it knows your music tastes so well. So this is the references. There's also, I included a paper that is like in progress that me and my friend is writing. And also these are the libraries that I used just as a reference if anyone wants to try it out. And this is the website. The code is not optimized, so it's really slow, but you can check it out. Hopefully, like, it won't break if everyone logs in at the same time. I've never tried that, so. Okay, thank you, everyone.